This is one of the most interesting optical phenomena I think I've ever seen. Right here is a tube that's full of a very dense sugar-water mixture. When you shine in white light through a polarizing filter into this mixture, you notice these colored diagonal stripes. Fully explaining these stripes is really challenging, but here's the basic idea. When you have sugar water and you shoot polarized light through it, meaning the light wave is wiggling up and down in just one direction, as it passes through the mixture, interaction with those sugar molecules causes this direction of polarization to slowly twist as it goes down the tube. So for example, if it started polarized up and down, by the time it gets to the end of the tube, it might be polarized horizontally or at some other angle. Now critically, the rate at which it twists depends on the frequency of the light. Higher frequency light, like purple, is getting twisted faster than lower frequency light, like red. So if you shine white light in at the beginning, by the time you get to the end of the tube, all of the different pure frequencies have distinct directions of polarization. Now you wouldn't be able to notice this just by looking down the other end of the tube. The light still looks white because it contains this mixture of all the frequencies. So one of the big mysteries here, even if you're an expert in optics, is why you see any evidence of that color separation looking at it from the side. Because it's not like we're passing the light through another polarized filter. It's still white light in the middle of that tube. The idea there is that when light bounces off of molecules, the water molecules, air molecules, sugar molecules, anything like that, and comes towards your eye, the direction that it bounces is not uniformly random in all possible directions. It depends on the polarization direction of that light. There's a lot more light that scatters perpendicular to that polarization direction, and in an idealized situation, no light is scattering along the direction of that polarization. So for some point in the middle of the tube, light with a certain color, like red, might be wiggling perpendicular to your line of sight, meaning you're more likely to see more red, while light of other frequencies, like purple, might be at different directions, more aligned with the line of sight, meaning less light would scatter towards you. This explains the variation in color as you scan your eyes from left to right along the tube, but that would seem to imply the stripes should be vertical. The fact that they're diagonal tells us there's also variation as you scan your eyes up and down. This depends on the fact that the tube is circular, and that the light is getting bent at different angles as it goes from the water through the glass tube and into the air. Last year, I got sucked pretty deeply into the rabbit hole of explaining each component of this mystery, and the result was a collection of videos about certain fundamental ideas in optics, like the very origins of what causes light, or what exactly we mean when we say light is slowing down when it goes through glass or water, and why that would depend on color. And I just love this, how you can start with a seemingly simple mystery, but if you tug on that thread with enough curiosity, it kind of forces you to wrap your mind around very foundational topics, useful to all sorts of other mysteries that you might encounter.